Welcome to Lab 10, Centripetal Motion. We're going to swing that stopper around and investigate centripetal force, acceleration, angular velocity, angular acceleration, and angular momentum. So we have a plastic tube and a stopper attached to a string and a paper clip that I've got a bunch of washers on. I've got 8 washers on right now, because I'm going to use them in the first exercise. So what we first want to do is measure the mass of the stopper and of the 8 washers. Now, along with the washers, I'm going to be swinging this thing around. There also is the weight of the alligator clip and the string. So, the string's not going to be that much. So let's go over here to my scale here. Drifted a little bit. Let's tear it. I don't know why it can't. There's something there. This LCD thing is sometimes. All right, so I'm gonna put the washer on so we can get a good value of the washer. 12.09. 12.095 grams, so that's 0.012095 kilograms. So on the other end, we're going to put our 8 washers. There we go, and string and the alligator clip. Get back on there. All right, so 69.971 grams. So for the first exercise, number 1, you're going to find the weight of the washers and the alligator clips and everything else. What now I have to do is set the radius. I forgot to do that before I go swinging. So let's. Oh, look, I've got my ruler right here. What I want to do is set the radius to be 10 centimeters. Oh, crap. The string got stuck underneath the iPad. Okay, I think I'm all ready now. So I've got my... so this is... put it this way. The centimeters are on the top of this stick right here. Inches are on the bottom. There, it's better. So if I put this at 10, now where should I measure it from? Probably from the center of mass. The center of mass, this is probably about there. That's a little bit of an error in here, not having the center of mass, right? So what I'm then going to do is I'm going to put the tube right about there, right where the beginning point is. Oops. So then I'm actually going to mark it with the alligator clip. So what I'm going to do is put the alligator clip right there at the edge. So when I put the alligator clip here, I know that my distance is around 10 centimeters from the center of mass for the length of the string. Okay, so now let's start moving this around. I'm going to put the iPad up on a little platform, and I'm going to try and, there we go. I'm going to try and time this. I've got a timer right here, same timer you've been using the whole semester, although we haven't used it that much, just maybe when we measure the velocity acceleration. So I have the washers. They're going to hang down and they're going to pull. If I'm not swinging the thing, the stopper goes all the way to the top and the alligator clip is down below. Well, watch what happens when I start swinging this. I'm going to have to move it up a little bit. I'm going to start it. There we go. If I keep swinging it, I can get the alligator clip to stay up. Now, if I let it slow down, the L clip goes down. If I speed up, it goes up. See that? Okay, so I am going to try and time it for, trying to see if I can see the iPad there. I'm going to try and time 10 oscillations. We're going to do this several times. All right, let's try our first one. I know it's really hard for you to do this because, okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that was 2.93 seconds. 2.93 seconds for the first one. And I'm writing them down too. I'm going to reset my clock and I'm going to start swinging again. Now it's kind of hard for me to watch my iPad the whole time, so if you lose sight, okay, now I guess you can see it. All right, so let's try and count again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's really hard to do, man. It's going so fast. All right, I got 2.88 seconds. 2.88 seconds. Okay, so we're going to try this a third time. Third time's a charm. Okay, ready? 0. Oops, didn't press it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3.18 seconds. So there's a little bit of variability on there. Okay, so we've got 3 values. You average them out to get a good value of the time and period. Now, each period is the average divided by 10. Let's do an example calculation of everything, and then what we're going to do is take the rest of the data.